Alright, so today we have this 2013 MacBook Pro Retina with the typical U8900 issue. Unfortunately, this one has had a prior repair attempt, which has made the issue a little bit worse, so we're going to be taking a look, going over the symptoms this board displays, and what we're going to do about it. So, first off, it came in with the complaint of no image. The device is already disassembled for me, as most things are before they reach my desk. So we plug it in, we get our fan spin. We need to check GPU and CPU vCore just to make sure we don't have a posting issue. But my guess is we're going to have CPU vCore and no GPU vCore. So here's our meter. And then I'm going to measure CPU vCore on these coils right over here. Where is it here? So CPU vCore is present. GPU vCore is 0 volts. Now let's see if how bad if GPU vCore is shorted. So I want to see if there's a short. I want to see what it is. Our MOSFETs probably aren't shorted to PP bus, so that's a good sign. But yeah, we have 2 ohms, so that's borderline normal. So let's go ahead and do the visual, and let's see what happened with this board and what we can do about it, because I have a feeling this may turn into be a little bit of a headache. So let's switch over to our microscope and have a look here. So yeah, so we have multiple components that are bridged, knocked off components. The flux looks to be corrosive and causing corrosion. I'm not sure what flux was used here, but this is overall a mess. So we're going to clean this up. We're going to wipe this whole area and replace everything here because none of this here is good. So let's clean this up. First step, I just want to get all that flux out of here to see what we can reuse. Probably not a lot of it. This flux, I'm not sure what type of flux this is, but it looks like it's kind of corrosive. And some fluxes are corrosive, so that's a definite possibility. A cap right there. The reason why I say it looks like it might have been corrosive is you could see that like gray oxidation on stuff, and that's typically what we see on liquid damage boards. So let's go ahead and put our flux down, and let's just get rid of everything here because I'm guessing not a lot of this is going to be able to stay. So anything that I see, any evidence of being touched, has to go away. So that includes the chip. That includes everything around the chip. And, yeah. Come on. I don't want to overheat the GPU either because the GPU is sitting right on the other side, but the heatsink is on there, so we should not reflow it like that. We just don't want the solder balls to melt under the die or under the chip because that would not be good. That resistor, both resistors are going because I don't know if they're going to be blown or not, and they probably are given how this looks. This resistor looks like it has a hole. So essentially it's just this entire area that has to go. Gonna move in with my iron now and just clean up all this and then clean it again because a lot of this, I don't know if we have any trace damage yet. I won't know that yet. The goal here is just to kind of clean up all the old lead-free solder and anything what's left of that flux so we can wick it and clean it. looks like we do have some trace damage right here. It looks, I can't really tell yet, it might just be corroded. Looks to be good, so I'm going to clean now with Q-tip and alcohol. Get on our fume extractor too. Alright, so looking better. Doesn't look as bad as it did before. Just go in here with a wick and clean up all of these old pads and everything right here so we could prep it for soldering of the new components. Then we need to figure out what goes where, and we could do that by just pulling the needed components off of a donor board. No need to overcomplicate things. Can't tell what's in this. We may have a ripped pad right there. It's hard to tell, so. Now we could clean up again. There, now I can see. So this pad is what I was concerned about. It almost looks like the component there shorted and burned the PCB, which is a definite possibility. I mean, you guys saw how this looked. Yep, that is burned PCB right there. Okay, so it doesn't look like it's going on the ground plane, and there is a decent enough pad right here. So I can make a bridge. What I'm going to do here, when I put that cap back, I'm going to kind of tack it here, but I'm going to bridge it to this trace, run a wire if I need it. This pad is intact, but this is the one we need to be more concerned about because it goes directly to the chip, and that should be alright. We could use a little wire, just as good faith, but I think we'll be alright. The main concern here is we don't want that cap to be bridged to this area, so I may just directly run a wire to the chip. But we'll see here. So let's look. Do we have any other nonsense here? Yes, we do right here. That's not too big of a problem though. In other words, I'm just going to start prepping this for new components. So we're just going to do knock out the easy stuff first, and then we'll move on to the hard stuff. Hopefully the GPU is alright. That's my main concern, that it got a spike from this nonsense. And that looks good. These resistors could use a little touching up, but those should be alright. Yeah, those are fine. Alright, let's grab a donor and let's start putting new components on here. Alright, first things first is I'm going to remove the ISL buck converter chip from the donor so we do not damage it when we are heating around it. Don't like unnecessary soldering cycles on chips. So I'm going to set that aside. I'm going to start with the bigger stuff. We have resistor. Again, I'm not concerned about how it looks because we're just tacking it down and it will be flown into place normal. Bridge is fine, that's just the trace it goes to because the conformal coating is scraped away. That is of no concern. Just double check on this other one right here because this may be a bridge, it may not be. Nope, that's the trace, that's fine as well. More flux in here. Alright, right here looks like we have, next to the big cap, we have a little cap. Wait, I think something is misplaced here. Yeah, okay, so we have little cap. It goes right there, and then looks like we skip a row, and resistors up here. Well, one resistor So we have one resistor there, skip one, no stuff, two capacitors. And then we have two more capacitors on these pads right there. Oh, knock this one off. Oh, that one blew away, so we'll get another donor on that one. We'll mark that one for later. Then I'm going to switch a pair of tweezers here because those tweezers are bent and they suck. Alright, next step is going to be these two resistors right here. These tweezers are absolutely amazing. I've tried so many like $30, $40 pairs of tweezers and they all suck. These tweezers, you get a whole pack of like 10 of them for $9 and they've lasted longer than all the $30 or $40 tweezers. Okay, so this is all no stuff. These are arranged right. We have a resistor and we have a capacitor. No, grab it. Come on. There we go. Then we have a resistor, then we have nothing, and then we have a resistor. And then we have a broken probe point, looks like. That's ground, that doesn't matter, I don't care. We have a no stuff again, two resistors, no stuff, no stuff, four resistors all there. That's pretty much it. We just have a couple that we need to fill in, and then the chip. So let's just get flux all around here. Let me just double check everything. With any luck, this thing will boot. I don't have high hopes though. I kind of feel like the GPU will be dead. Simply because the GPU is very sensitive to voltage spikes, and this chip supplies voltage to the GPU. So if this chip screwed up and accidentally switched 12 volts to our GPU, the GPU is probably not going to have survived, but we'll see. So I have another resistor missing right here. Looks like it's for current sensing. And then that one cap right here. That's it. Now our chip. Hopefully our GPU will be okay. I cannot tell you how much I'm concerned about the GPU, but we're gonna find out here. Check chip for bridges. Looks good. That is in place. What's this on the top of it? Is this... That's nothing. Alright, now let's let the board cool down for... I'm going to give it like 2 to 4 minutes because the GPU and the heatsink is hot. So let's give it a few minutes and we'll be right back. Alright, our board is sufficiently cooled down now, so I'm going to go ahead and plug it in and see if we get GPU V-core back. So GPU V-core should be around 0.9 volts with the GPU is not under load. I think it boosts up to like 1.1 or something if the GPU is under load. So fan is spinning, so we didn't make it worse. And GPU V-core is 0.902 volts. That's great. Now the next challenge is... do we actually get into an image? Do we get an image and do we boot into an operating system? So let me go grab the enclosure of the computer and attempt to boot into an OS here. Alright, we have our USB test SSD plugged in. Let's go ahead and plug in the charger and see what this does. So we get our fan spin as expected. Chime. Yep. We chime. We get backlight, which is a good sign. You probably can't see it because there's glare. Let's see if this actually will boot into an operating system because that's the real test. PCH temperature is normal, GPU is warm as it should be, CPU is warm as it should be. It'll always take a minute to see the SSD because the SSD is not set as its startup disk, so it'll take like 30 to 45 seconds or so to see the SSD. There we go, Apple logo. And a progress bar. So that is a very, 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 very good sign. So what I'm going to do is open this. I'm going to open a GPU stress testing program, and we will see if it's able to run that without crashing. We have a cursor here. And it booted. So let me enter my test disk password, which is a very secretive password that starts with 1234. Not much you can do with a test disk. Alright, so we're booted. Our GPU is definitely working at this point. So I'm going to open Unigine Valley right here. And let's see. I'm not going to go super crazy because the thermal paste is probably baked. We'll just go medium anti-aliasing to X and run. And let's see if this is able to render 3D. It's going to be throttled, but because the battery's not plugged in. Maybe it'll be alright now. I just plugged the battery in. Loaded the program. It's making the noise. Can you render 3D, GPU? And it's rendering 3D at a good frame rate. So this should be fixed, surprisingly. So looks like no permanent damage to our GPU. And looks like this thing is good to go. So we're just going to ultrasonic the board, reassemble it, and that's about it. So thank you for watching. And if you if you're not 100% sure, do not practice on a device that's working. Practice on donor boards first. Again, not anything negative because this customer wasn't a repair store, so it's if it was a repair store, I get really angry at this stuff, but this is an end user customer that tried to fix their own device. So again, to end users that find yourself in a similar situation, buy a donor board, buy something that doesn't work first before trying to fix your own laptop, because oftentimes your first board really doesn't turn out well. So just a word of advice there. But this appears to be fixed. We're holding good frame rate. GPU temperature is 66 Celsius, 68, which is perfect. So again, ultrasonic, fresh thermal paste and reassemble, and probably 12 hours of stress testing, and this is all set. So thank you for watching, and I hope this helps you. This video helps you in some way.